So this first technique we're going to discuss is one you may have learned in school. This is called the product rule. So we're going to take the product of d dx and x, and that's just going to be dx. We're just multiplying the numerator by x, and we can cancel out dx and dx, and all we're going to have is 1. This next one is going to be a pretty easy one, the derivative with respect to x and x squared. In order to do it, I'm going to use a by now fairly well-known property called the Yeet theorem, which is that a to the power of b, we can just yeet down the b to get ba. Here's a little proof for those of you who desire a little more rigor than just a statement. 5 squared, we can yeet the 2 back to get 25. 5 to the 3, that's just 5 to the 1 plus 2. Bring that back to get 125. 5 to the 4th is just 5 to the 6 minus 2, and that's 625. And with that, we've got 3 cases, so that proves the entire statement for all values of a and b. Now, coming back to this one, you can now see all we have to do is yeet back the 2, and we have 2x. It's as easy as can be. So to take the derivative of sine of x, it's just going to be cosine of x. Now I know what you're thinking. Why is that? What method do we use? Well, you know, it's just cos. So we now know the derivative of sine x is cosine of x. The derivative of cosine x is going to work much the same way to just get back to sine of x. The thing is, it's not the same thing. In fact, cosine is really just a close cousin of sine, so we're going to have to throw in a minus here in order to get our answer. So now that we have the derivatives of sine and cosine under our belt, we may want to take on sine divided by cosine, that is tangent of x. We can't just divide them, that's not how derivatives work. So instead, we're going to say, well, let's assume we already knew this. Let's assume this was a known derivative. Well, then we could probably get the answer in 2 seconds. Now we're going to be coming back to our Yeet theorem, and we're actually going to invert it. We're going to take the equal sign the other way, if you will, to say that ba is equal to a raised to the b power. We're going to inverse Yeet this 2 up to get second to the power of 2. And of course, because this is with respect to x, and I don't see one here, I'll just write that in. And there's our answer. Fuck it. So this is one that a lot of teachers will say is just defined that way. That there's no way to actually evaluate the derivative of natural log of x, and it just has a definition of what its value is, but that's actually not right. And I'm going to show you a way you can actually calculate this expression right here. So notice first about this ln of x that the lowercase l kind of looks like a 1, doesn't it? So that's going to be 1n x. Now I think it was Pythagoras himself who once said you can add as many apostrophes in the middle of your math as you want. So we're going to rewrite this as 1 apostrophe n apostrophe x. So moving on to the next line. This sounds like 1 and x, right? 1 and x, you know. So that we're going to write that in. And at this point, we may as well just write a plus sign, right? Now, okay, let me ask you this. What would you say about a number that was equal to 1 plus x? Well, it's 1 more than x, or you might even say that number is 1 over x. And look at that, folks. That's our answer right there. So here's another neat use of the product rule. Well, if you look at this, derivative of 1 over x, we can multiply these together, right? The d's are going to cancel out. The x's we can multiply together, and the 1 will leave as it is, so that we get right? So the d's are gone, the x's are multiplied together, and the 1 doesn't cancel with anything. So now you'll notice we can just use, multiplicative commutativity, a nice property, to just kind of shift this x squared over to get our answer. Alright, I'm gonna be honest, guys. I looked at this one for like an hour and a half. I tried every tool in my toolkit. I even tried phoning up my ex, actually. Nothing worked. So eventually I caved, and I plugged it into Wolfram Alpha. And I learned that the answer is actually 1 plus the natural log of x, all of this times x to the power of x. Very easy way of getting the answer in a pinch.
And here, folks, we have some behind-the-scenes footage